Hello everyone. I wanted to explain the second part of the friction experiment, where in this case we have the wooden cart. It has a single weight on it, and there's a string connected to the cart that goes over this pulley, and it's connected to a suspended mass over here. Okay. The idea of this part of the experiment is to calculate or to try and estimate the tension in the string, and we can do that experimentally. And then we can also look at all the forces acting on this cart theoretically, and we can calculate that tension in the string. So we want to compare the tension that we get experimentally to the tension in the string that we get theoretically when we calculate it. Okay, so how are we going to do this? Well, what we're going to do is we're going to vary the amount of mass you put on the hanger. Okay, then we can calculate the weight, right, of that mass by multiplying by 9.8. And the key thing here is we're adjusting this mass such that the cart moves pretty much at a constant velocity. Like if I give it a little touch, it's moving slowly, pretty much at a constant velocity. So why does it have to be a constant velocity? Well, remember, if something is moving at a constant velocity, then it's not accelerating, so there's no acceleration of this cart up the ramp. Therefore, the net force has to be 0 acting on the cart, and then tension would be constant, right? So if it's moving at a constant velocity, then this tension is going to be constant, and we can easily figure it out. In fact, it's easier to look at the hanging mass to figure it out. So if this cart is moving up at a constant velocity, that means that the hanging mass is moving down at a constant velocity. So just like the cart, it is not accelerating, right? So it's just moving at a constant velocity, no acceleration. Therefore, the net force acting on the hanger is got to be equal to 0. And we know the force down is going to be the weight. So if I multiply the mass times 9.8, that'll give me the weight. And the force acting up must be the tension in the string. So since there's no acceleration, the tension up must equal the weight down. So the tension in the string is simply going to be the weight once we calculate it. So depending on how much mass we put on here, we can calculate the weight, and that gives us tension in the string. And we do that for several different angles. So I start this at 20 degrees, and I'm going to vary it all the way up to 85 degrees, which is pretty steep, something like this. Okay, and the tension is going to vary, right? And it's pretty complicated, and you guys will see this when you look at the theoretical formula. So we have tension pulling up, but what other forces are acting on the cart? Well, we have a weight, right, towards the center of the earth pulling down. We have a normal force that the ramp exerts perpendicular to the ramp on the cart. And we also have a kinetic frictional force, once it's moving, kinetic frictional force acting parallel down the ramp. So as we change the angle, those forces are going to change, right? The weight, at least the component of the weight that's along the direction of the ramp, that's going to change depending on the angle. The normal force is also going to change depending on the angle. And remember, the friction depends, the frictional force, the kinetic frictional force, depends on the normal force. It's equal to mu k times n. So that's going to change as well. So it's pretty complicated, right? The tension depends on the angle, right? And again, we'll compare what we get experimentally just by putting on these masses and computing the weight of the hanger here, which would equal the tension in the string, to what we get theoretically when we calculate the tension in that string. Okay, so anyways, that's the idea behind this part of the experiment when it's moving up the ramp. Thank you.